Good afternoon, morning, wherever you are. This is Lee McClure. Welcome back to the second workshop on logging and monitoring. This class began a week ago, Monday. We're in the second week. Last week we covered lessons 1 through 3, setting up the basics of what logs are, talking about reading logs and analyzing logs. And this week we're going to finish up with the logs with a lesson that I'll cover fairly quickly because it's mainly case studies. Lesson 4 on interpreting logs. And then we're going to spend the rest of the session, and it's going to be the main part of what we show and do some demos on, is we're going to talk about intrusion detection and intrusion prevention, and in particularly dive deep into the tool we have been used a little bit in network defense, and now we're going to be using in this class, which is the SNORT intrusion detection intrusion prevention system. And so we will cover lesson 5 on the sort of conceptual stuff around intrusion prevention and detection systems. And then we'll look at the SNORT configuration within lesson 6. And then we'll even look at custom SNORT rules within lesson 7. So we're going to go over all of that. So let me just go over quickly lesson 4. Now, last week we talked about what logs are, right? They're just generally textual. They can be in database or binary format, but they're usually some kind of delimited data, usually space or tab delimited data. So there's just columns of data. There can be a timestamp, there can be an IP address, like in the web log, there can be what page was requested, a status code, or it might be the timestamp and the process ID, and whether it was an INMAP, whether it was a POP or an IMAP connection, if it was a mail log, on and on. All these systems, system logs, application logs, server logs, all the different types. And, they're fairly easy to read in and of themselves. But what the challenges get into is having to not only look at one log, but look at multiple lines of a log, right? Many times, as I showed you last week, one single thing on like one web page request can be multiple lines of log files, multiple entries, because your browser asks for the web page, it then asks for the style sheet, it then asks for the JavaScript, it then asks for the logo and the menu graphics and the sidebar ads, and you end up having all of these requests that each one of those is an individual log entry. So to see what that one, to get the one web page, you have to read all those lines. And then of course, if somebody clicks a link, they go to another page, then we're going to have to look at a whole nother set of entries. And to track that user through our website, we're going to have to read a lot of different lines and be able to analyze those logs. But what if somebody does something broader? What if, which is very often, like somebody's running scans across your network as part of recon for a future attack? What is that going to look like in our logs? Well, it may look like, a series of separate incidences, right? Like, because these scanning tools might be trying to, attempt a login or a scan and a port scan to see if the service is up. And so we might see an entry in our FTP log, and we might see an entry in our web log, and we might see an entry in our SSH log, and we might see an entry in our mail log, all of which are coming from this same source. Or as has happened in the case of the case studies, an example of the case studies that are in lesson 4, there are 2 different case studies. They mainly revolve around web logs, but really in reality, other logs, including access logs just on the system itself, database logs, and other things were looked at to analyze and interpret this event. And so in a nutshell, there were 2 events. The first case study involves a copyright infringement and what then escalated into an identity theft attack. The web logs were able to basically, and email logs were able to provide a story that that could be analyzed to tell the story of what happened. And so the high level of the story is that, an entity out there that had information on their website, they had that information basically snagged, and it was being republished on another website with no attribution, no licensing fee. They were violating the copyright of that material. The management of the entity that was being infringed basically sent kind of a cease and desist kind of thing. Hey, look, you need to take that down, or we can work out a licensing deal and you can publish our content, but we need credit and a fee. And the person who had snagged the data was of a mindset that data was free kind of thing, and that wasn't necessary, and began to respond to the threat of the cease and desist letter, instead of either just taking it down and moving on, or working out a deal that would have been mutually beneficial. Decided to retaliate against the management of the original entity by signing them up for all kinds of, in many cases, not really safe for work, not appropriate, and nothing wrong with any of the niches that might have been used, but they just weren't appropriate for those people. Kind of embarrassing in some cases for them to be on these strange niches and these groups and these mailing lists. And these people started getting all these emails that were saying, thanks for signing up for, I mean, I'm not, like I said, there's nothing wrong with any of the groups. It was just, it was an identity theft, a spam, an attack on them. So they started getting tons and tons of emails saying, thanks for signing up for baby support monitor. Thanks for signing up for whatever, extreme, sex group, or thanks for signing up for whatever support group, on and on. Just hundreds and hundreds of these things started coming in. So they started getting bombed with all this mail, and somebody out there is impersonating them and signing them up for these sites. But of course, one of the things that person didn't realize is that their IP was being tracked, and in some of the cases, in the email logs of those servers when we worked with them, and in the emails that were sent to the executive in question, the IP of the signing up, the person who did the sign up, was actually documented as part of the sign up process. We were able to then go back and look at the web logs and the mail logs and things like that, and find out where all this IP had gone, and prove that the IP in question belonged to a certain individual who was the party to this case. And this thing went all the way to federal court kind of thing, and had to be testified about with, as you'll learn later in the lesson, proper forensic control of the log files and chain of custody, and being able to have somebody act as an expert witness in the trial to interpret those results for the jury in question. The second case was an anonymous SQL injection attack that managed to, do a degree of breach into a database, get into the back end and read some data. That was then ultimately analyzed and once again covered in the, sorry, I can't read one of my little notes. Hang on a second. One of the big things that is something to take away is to see what, and there's examples in the lesson of what that attack looked like in the web logs. And it's something that is a pretty standard kind of looking signature. You can almost always tell something's up when you're looking at web logs and you're seeing embedded SQL statements basically in your web logs. So somebody was attempting to inject that SQL in. Whether it was successful or not will obviously depend on your application and code and the security you have in place. But in this case, the attacker was able to get in. Then they tried to come back. There was a lot of back and forth, and ultimately they were tricked into revealing their real IP address. And so they're interesting cases that sort of tie up that first part. So, all right, so then moving on, when we talk about lesson 5, it goes all the way, this whole section 3 lessons here is lesson 5, 6, and 7 are all about basically intrusion detection and intrusion prevention. We've defined these before. And as I said back in network defense, intrusion detection and intrusion prevention systems are really kind of two sides of the same coin. In many cases, it's not so much that you go buy an intrusion detection system that can't do in prevention, or you buy a prevention system that can't do detection. The reality is most of the time, these systems, Snort, for example, can be configured to do either. And so it's more about how you actually set the things up. So like if I go, and let me make sure I've got everything where I want to have it. Let's see here. Okay. So if I share my screen here, and we are staring at our topology that we've been using now for a few classes, you'll notice that I have added an intrusion detection, and of course there should be one down here. This is my own variant of the topology because I was showing it for network defense, but it's pretty much the same topology, so I'm using it here in our logging and monitoring class. The difference is the intrusion detections are here in both cases, right? So But one of the things that you'll notice in both of the cases, like you should have another IDS down here in the LAN, but you'll notice that we have it connected to the switch on port 4. And if you remember back in network defense, one of the things we did was we set up port mirroring on that Etho4 so that it could see all the traffic going to ports 1, 2, and 3. And the 0, of course, is connected to the switch. And so the LAMP server, the Metasploitable, and the damn vulnerable are all having their traffic going out those ports mirrored over to the to what's going on. And that allows the intrusion detection system to see all that traffic and monitor multiple machines at one time because of that port mirroring. But this is what's called a passive or out of band model of intrusion detection. In other words, if you think about like if this Kali Linux machine was our visitor or our attacker, their traffic comes through the outside, goes through the router, comes through the switch, gets sent to whichever machine they're trying to reach, right? But it's not going through the intrusion detection device. As a matter of fact, that box doesn't even have an IP. It's not on the network at all, really. It's only mirroring and reading everything passively. If we wanted to actually set this up as intrusion prevention, we would have to do a couple of things. One, we'd have to have an appliance that had more than one interface, because we would want to put it what's called in line or in band so that it can actually take action. And so it comes down to that instead of having this intrusion detection be passively connected to the switch, we would want it to be right here in between the switch and the router. And we would literally have a cable going from the router to the intrusion detection, and then another one leaving on another network adapter out the backside from the intrusion prevention to the switch. Now we've put that device or this Snort appliance in line with the traffic. Now it can actually take action, because instead of just seeing some weird attack go through a SQL injection or something and throwing an alert and paging the admin, it can actually see that traffic and drop that traffic. And that's really the key difference between intrusion detection, generally done in a more passive, out of bound, offline, not offline, but out of the path. So that's kind of the difference. This over here, what we've done is we've set it up to use a mirrored arrangement, so it's passively monitoring the network. If we wanted to actually have it be a prevention system, then it would have to live in between, and it would need two network interfaces, and it would need to be configured in as such. So one of the things that I'm not going to go fully through, but I'm just going to, in the lesson, it takes you through coming to edit preferences, coming down here to, oops, not patient enough, Docker containers, and then adding a new appliance. I have a number of different appliances, including the Snort appliance, but it only has one adapter. And so to make a prevention system, we would have to tell it, okay, I want to do a new, obviously we run it in the VM. We are going to use an existing, unlike most of the time we've been putting in a pull path, right, to get it. But in this case, we should already have it. And so we go down to the one we want to use, which is the WASU Snort. And then this is the real, and then the name, we're probably going to call it something else, like inline, or we could call it maybe IPS, right? Something so we know that this is the one that we've configured to handle, to be an intrusion prevention version. And then the big thing is you're going to have to give it at least two network interfaces here. So that way you can have traffic go through this device. And of course, once we do that, we can go ahead and tell it, I'm going to cancel. But at that point, what we would have would be a new device would show up on our list. When we drag it in, we can wire it into the topology however we would like to. You have an exercise in this lesson, or your exercises in this lesson. You're going to be setting up some sort of conceptual networks. You won't be doing it in the topology. You'll be just building some new projects. And you will need to drag in a few things and do some base configuration to kind of show in principle that you've set it up in the different modes: passive intrusion detection, inline, active intrusion prevention. And so you'll need to go through some of those steps. But for the most, so while there is a little bit of hands-on, just playing with some variants of Snort, in reality, it's really more of using it as a diagramming tool to create the networks and the appropriate structures to do intrusion detection and intrusion prevention. And lesson 5 is mainly a conceptual chapter. What I thought, cool. So now what I want to do, sorry, I was cleaning up here a little bit from the last class. We want to talk about Snort itself. And Snort lives on, of course, any of your, you might have a third one now you've added, or but we can come back to the topology. We want to do this in the topology. So lesson 5, you'll make a few other standalone or in a separate project and do your different configurations for inline and passive IDS, IPS. But you'll come back to the topology in 6 and 7, and we'll actually be playing with and going and doing some exercises with the configuration. So I'm going to come over here. I've got a command prompt open on my Snort IDS system in the topology in the DMZ. Going to get myself a little bit bigger font. And then you'll see that I'm already in a folder, which we could have gotten to with this command, etc snort. I'm already in that folder, but that's the command that would get us here, change directory, cd space /etc/snort. All of the configuration and rules for Snort live here. This is actually a persistent folder. In other words, if you make changes here, then you can, they'll stay from one boot of the topology to another. In lesson 6, we cover kind of Snort and it's sort of high level what's all in here. So if we take a long listing, ls space -l, you'll see we've got attributes and classification information. We've got pre-processor rules, SO rules, and then of course a threshold and probably the most important file in here, the snort.conf file. As I've said before, the etc folder system, and we've played with it all the way back to Network Foundations when we had to go into etc SSH to configure SSH servers, right? And disable the password functionality, for example, and things like that. So generally under the SSH folder structure, you will find the configuration files and the configuration setup for your software that you have installed on that system. In our case, etc snort is where we have all the configuration and rules that go with the Snort appliance and the Snort software. Now, one thing is that I recommend that you actually copy your snort.conf and either make a backup copy, or you can, call it something like Snort working, whatever you want to. This way, you can have as many as you want. Since Snort is started at the command line and you actually pass in which configuration file you want, you actually in the real world could have multiple configuration files. You could have one written to be in intrusion detection mode, another one for intrusion prevention mode, another for their just packet capture analysis mode. And you might have it different configurations you might have one really, really nice setup Snort machine that actually has multiple network cards and it's monitoring different passive networks. So you're running, in a sense, almost multiple Snorts. One's watching this part of the network, one's watching this part of the network. It's all going to depend on the traffic and how much machine you have. More times than not, you'll have multiple installations of intrusion detection at different places in your network to look for things that might be going on, right? But the idea is that you can have multiple snort.conf files, and as part of doing this exercise in lesson 6, you're going to have to edit the snort.conf file. So the idea of having a backup copy, I mean, worst case, you could always re-import the topology, but that's kind of a pain, right? It takes a while. So just be smart here. Make a copy of your snort.conf file, leave it alone so you have that default one, and then you can start working on the other. So if we go look at Snort working conf, and I'm just using Nano, you can use VIVM if you want, but you'll see that this is just a text file like any other conf file. When we have the pound sign hashtags, those are comments, right? So all the stuff at the top just tells you that it's part of the Snort conf, and then it tells you right here, this file contains a sample Snort configuration, the following steps. Set up your own network variables, configure these different things, and you're going to see that we don't do all of these, we only play with certain parts. Most things we leave at the defaults, but we do want to know a little bit about one, setting up the network variables for your network. We want to know a little bit about output plugins. because we want to be able to know how to output this data to like a log file or something, as opposed to just having it be sending it to the screen. And we'll talk a little bit about rules, particularly more in the next section as well. So when you come on down, you'll see step 1. So here's the network. Now, what you're going to see is it says set up the network addresses you are protecting. And what it's done is it's actually defined a variable IPVAR called HomeNet, home_net, and it's set it to the value of any. So out of the box, Snort will monitor any IP. So that's why it would work like it worked in network defense. You put it into that port mirroring situation, it can monitor traffic going to those addresses. But if you want to make Snort be more focused, then you're going to give it the IPs. So like, for example, in our case, our network is 10.10.10, right? 10.10.10.0/24 or whatever the model. And so we could limit Snort to not necessarily paying attention to other parts of our network. Maybe we want to have multiple Snorts, and one's just going to watch the firewall, or just going to watch the web server, or was going to watch one segment of the DMZ, and another was going to watch the secondary segment where the database servers are. So we want to define them so they're not necessarily trying to track and monitor traffic to things they're not responsible for. They work out of the box, any, and then you can see as we set all these other variables, what's the external network? Well, everything is. What are the DNS servers? Well, they're using the $ HomeNet, so basically it's any. So every answer right now is HomeNet, any. SMTP servers, any of them. HTTP servers, any of them. But the reality is, if you're really configuring this in a live deployment, you would want to set those to your servers so that Snort doesn't have to waste time looking for vulnerabilities on a SMTP, a mail server, if that IP is not a mail server. If you've said it's a web server, it's going to try to protect it. Now, it's going to, to some degree monitor, but this is configuring Snort, so it focuses on what you want it to do and only monitors. And you'll see it has SMTP servers, SQL servers, SSH servers, FTP servers. So this section of the Snort conf file is one in your own copy again that you're going to want to modify to match our network. And you'll have to do that for the DMZ. And I think you do it for the LAN too. So you'll have to set up the right network range and then define which machines. So if you don't remember which of the machines, say in the DMZ, are web servers versus which ones are database servers versus which ones are SSH servers, then you'll need the Nmap. Good practice, right? Nmap all those machines, see what ports are open. If they're running that service, then you're going to want to list their IP in the appropriate section. So part of your homework is to configure this part, section 1 of a Snort conf file. Then there's a lot of, and we don't even do a lot of this stuff further down. We're just talking mainly the main, the ports are usually fine. So we're talking about the first part through the IPs, if they're appropriate. Then a lot of this stuff can stay the same. And then we just skip through all this decoder. But I want you to pay attention, look at what's on, what's not, how you could turn things on by uncommenting. Certain things are uncommented, so they're in process. We're down to the third part now, the detection engine. We're just using all defaults. If we wanted to turn other things on, we could. We can turn other things off. We're going to come down, further and further. It's a big conf file. Another reason to definitely have multiple copies. When we keep coming down here, we're finally going to get to 6, which is output options. And you'll see that all of these are commented out. There's a unified log format. There's syslog, PCAPs. We can do different types of output alert formats. And you can see that none of these are on at the moment, though we do pull in these classification and reference config files to help define these logs. And so if we wanted to do, it says recommended for most installs. So basically we're going to, output a merged log file that has all the data in it in one place. We could also potentially do, tie it into our syslog system, send it to a syslog server. We can create different types of output, either based on logs or alert, right? By just uncommenting these lines. I've now turned, if I save this file, restart Snort with this config, then I would be outputting in this alert unified format. I'm not going to save this because I'm not making that change, but this is what you're going to need to do in this exercise, is kind of get familiar with the Snort configuration, and you're going to need just a few sections. You're going to edit it. Now, one of the last ones is when you come down here, it says rule set. and you'll see all these rules are on: browser attacks, denial of service, DOS, IP, FTP, different types of malware, Oracle, OS policies, POP, protocols. So these policies are all being included from the rules folder. Well, this is another section you will need to do a little config, and this is all kind of a thought exercise. If you were, the theory is you're setting this up in our network. So instead of just using the everything wide open and do everything defaults, what would you do to really set this up to work with ours? So if you think about it, when you look through some of these things, you know, for example, we might look through here and go, and I guess I'm gonna give you one, but if you watch the video, you'll get this. But like, to my knowledge, there's no Oracle anywhere in our DMZ. We have ProgressSQL, we have MySQL, we have other types of stuff, but we don't have any Oracle. If you don't trust me, scan all the machines, right? Metasploitable, maybe the only one that could. The others I know don't, and actually I actually do know that there is no real Oracle database running over there. It's not open source, so it would require a fee. That's why it's not in there. So we could theoretically comment this rule set out, and Snort would then not be looking for any Oracle stuff, which would speed it up and let it focus on other things, right? So the idea is that some of these rules you might be able to get rid of. Other ones you can't, because of the either, like you can't get rid of POP theoretically because we have mail servers. And so theoretically we'd want to make sure that there wasn't a kind of some kind of POP attack going on, post office protocol attack. So, but that's the gist of basically, say no, I'm not going to save anything. This is the gist of basically lesson 6. You're going to spend some time getting familiar with some of these config files. The only one you're going to mess with is the Snort comp, or your copy of it, but you're encouraged to look through some of the other stuff. So what does the classification file do? Well, this is used for prioritizing rules. It makes sense since it was brought in and included during the rule segment there in the output, right? So it sets various classifications: not suspicious, attempt. So these are classifications that it would potentially log into one of the logs it produces. And if you needed to create your own classifications, you could modify this file. Most of this, of course, is done by the open source community, and probably most of these defaults will work for you just fine. But if you needed to, you could make a copy of this and edit your own config thing, right? So the main file, though, that we really do work with is the Snort comp file. I made a working copy with the CP command, right, so that I didn't have to mess up the original, so I could go back and compare if I messed something up, or I could start over. Now, then the other thing we need to talk about is in lesson 7. In lesson 7, we talk about Snort rules. So let's clear up here and change into the rules folder. You'll see now I'm in Etsy Snort rules folder. And if we take an ls, boom, here's all these rules. Now we just saw them actually, because like here was, where is it? It's got to be right around here somewhere. Oracle. This is the actual rules for Oracle detections. That was listed in the config file. So if we didn't want it, we could comment that line of the config file out. Technically, if we deleted it from here, it would make the rules not work, but we probably wouldn't want to do that. It's better just to comment the one line, right? But let's just forget, what does that rule look like? Well, there's the usual comments at the top, and then actually in this case, there are no rules. It's empty. So this whole file is totally just commented out. So no rules in that case. Some of them may not have anything. Some of them might be zeroed out or empty like that, because if you notice, you can kind of tell this smaller files, they're probably just the base. And then some of these bigger files are specific, you know, types of things that we might, browser issues, other policy issues, certain protocols. So there's SCADA rules. So anytime you see a bigger file, server, MySQL rules. So we can look at that one instead. There's server Oracle. Maybe we can see if there's something there. So server, oops, Oracle, not ISS. Now we've got some rules. This rule, and don't worry about it, I'm going to go over rules and how to interpret them in a minute. But that is, now this one's commented out, you can see, but that's a rule. It's saying that we're going to throw an alert if we see any traffic from the external network coming into any port of the home network with the message Oracle server, Oracle Web Center, FatWired, server header injection. So it's looking for certain things based on certain rule sets. So some of these are commented out. If we go through here, some of them might not be. It looks like many of them are. But you can see these rules are available. Many of these rules are written by the community, and some of them are not populated fully in the community edition. You have to get the sort of higher level rule set, and of course you can make your own. And there's a lot of discussion and sharing in the Snort community and websites and forums too. Now, if we take a look though, there's one really important one in here, right here, called local rules. These are rules you've made yourself. These are rules that you want to add to within this suite. So if we take a look at local rules and come down a notch, you're going to see that there are a very few set of rules though that I have created, and they're all down here, and I'm going to go through them all. They're not as complex as some of those others. As a matter of fact, they're pretty easy, because you'll see like the first one says that this is an alert rule, and the lesson takes you through this and takes you through the syntax and sort of syntax of these rule structure. But these are kind of at their barest minimum. They can be more complex, they can have more options, but at the barest minimum, to get a rule to fire, then you need to define whether it's an alert rule, a log rule, what type of rule is it? Generally going to be alerts in our case, though you can play with other things if you want. Sorry about that, some noise in the background. Maybe a neighbor outside or something. But anyway, alert rules. And then you have the protocol in question. So in this case, ICMP, or like down here, we've got TCP, you could have UDP, protocol, or transport protocol. And then we have where is it coming from, which in this case, we're using that just like from the config file. That word any is a keyword in Snort that says, like it means any. So from any IP to any port, because these two bits of the rule are the address and the port. So we're saying here, when we read this all out, any ping, any ICMP traffic, technically a ping, could be other type of trace route or something. From any address out in the world to any port, from any port coming into our home net, which right now is also, remember from the config, is defined as any. So basically we're saying anytime, anywhere somebody tries to ping anything inside of our network on any port, we're going to flag this IMCP connection attempt happened. And then you can come down, they're all pretty simple. Where I got another rule here that says alert if it's TCP traffic from any place and any port out there to any IP in our network, because home net, remember, is a variable defined as any until the config is changed. But then we're going to define the port 21. So if we see any connections over TCP from anywhere in the world coming into any IP of our network that goes to port 21, then we can assume that's an FTP connection, right? Or at least an attempted FTP connection. And then you can see the rules again. And of course, if we only wanted to know certain things, like we could set a particular IP range in here. If anybody from XXXX or comes from a particular port, or if we only want to have a rule when somebody tries to go to a particular server on a particular port, we can put the address into the rule. But we can use these variables that go back to that Snort comp file, right? And so what you're going to see in these couple lessons is in lesson 6, you're going to need to make your own copy and do some configuration of the Snort comp file to make it more tailored to run within, say, our DMZ. So you're only going to want to list the machines in the DMZ that are, in those appropriate categories. You're going to want to list the mail servers in that category, the web servers in that category, etc. In this case, when you get into the rules in lesson 7, you're going to get to understand the rule syntax. We're going to you're going to go through and look at some of the different rules. Even as part of the previous lesson, you're going to think through, well, maybe some of those rules don't apply to my setup. But then the other side happens here. It's like, okay, well, I've turned on certain rules, I've turned off others, but maybe I want to create my own for my own purposes. I want to, I'm really worried about a particular database server being attacked. So I'm going to create a particular rule for that IP and that port. And if I see any traffic that meets my flags, then I'm going to alert on it or log on it so I can be aware of it. There are a number of rules that you could create for just about any combination. And in a way, if you think about it, these are similar to firewall rules. Now, a firewall rule says if I have traffic from here and this port going from here, then I will block it. I'm not sure what that all is, but I'm sorry. So anyway, we'll block the traffic. In the case of intrusion detection, we're not going to block, we're just going to alert. And in case of intrusion prevention, we could set up a rule that said, if I see this, instead of block it, let's take action. And let's actually stop that. Let's call and add a rule to, update our firewall to drop that traffic as it passes through the intrusion prevention system. Now, the one last thing that's talked about a little, and you play a little bit with in this lesson, is as we saw in the Snort conf file, you can set some output options for how you want to output Snort log data. It can even be set up to integrate with the syslog systems, right? So if you were running a centralized syslog server, Snort could drop some of its alerts and stuff right into your system. And it can be made to work with other systems too. Now, because of our limitations of our, topology, we already have a lot running in it, so there's only so much more we can add. I tried actually, but I really can't build a very elaborate kind of one of those acronyms from this class, the network security management, the security incident and event management systems. They're pretty elaborate. They require multiple databases, etc. So to get one of those to run within our topology on top of everything that's already running is a little more than we can ask of the average student and our 8 gig minimum. So, but I was able to, at least in principle, I was able to get to work and students can play with to get an idea of how you can integrate, at least conceptually and high level, things like Snort with other tools. And there is another tool called Graphite that's out there. It's something that can be added theoretically into the topology. You don't necessarily have to do that and run it per se, I don't believe, but what you are doing is playing a little bit with setting up a special rule in Snort that would allow you to basically export the tool, the data to that tool. And so you might find something like that with other tools out there. If you go to work someplace, they're using, open OSSIM software, or they're using IBM's software, that they bought for SSEIM monitoring. And so they already have, or you're thinking, hey, we got all these Cisco stuff, but maybe we should put a few Snort appliances around or a few pieces of hardware just doing some monitoring, and we want to dump all that in. There's no doubt a way to get that data, either through syslog or through certain formats. And so there is some talk about this other tool. Graphite is actually more of a visualization tool, but that's important given the sheer overwhelming amount of log data we actually generate in a typical IT infrastructure, and trying to sort the needle from the haystack of the potential probes and attacks and things that are happening, to be able to see not just all this raw log data, but a lot of visualization, graphical interpretations, pie charts, bar charts, other kinds of things that might help us be able to see the pattern or ferret out some information. Remember, once again, the whole point of all of this is to maintain situational awareness. We want to know what's going on our network so we can defend it and respond to any incidences or breaches that happen, so we minimize and mitigate any ill effects of those and keep the damage to our reputation and to the company and the bottom line, etc., as minimal as possible. So, so the first week we talked all about logs. Now we've gone a little further. Now we're generating more logs, theoretically with Snort. We're generating more data, but Snort's a different way. Instead of just going and looking at logs, Snort now can actually be part of generating that and analyzing that data and helping us respond to it, throwing alerts when we see certain types of activity, certain rule breaches happen. And then, it's going to need more configuration, obviously, and this is just in a sample. But the idea is to give you some exposure. So over these lessons, you will play in lesson 5 with some conceptual You'll build your own topologies and build a passive IDS setup and a more inline IPS setup. You will do some snort configuration work in 6, working particularly with the snort configuration file, with the section at the top on the networking, with the section on the output rules, and with the section on the rules, making changes that are appropriate for our network and our topology. And then you will get an overview of all the wonderful rules and how the rules work, and even be able to create your own rules, because all of these files maintain their state. So if you wanted to add another rule, you simply can add another rule, right? I mean, I can do that real fast. It's just a simple thing. If we actually come in here and edit local and scroll down, it's actually really easy. So let's just say we wanted to do a rule to alert for the web. So we're saying here we want an alert rule that's going to alert on TCP traffic from any address and any port coming into our home net. Or we could even, just to show how it's done, let's just say it's going to 10.10.10 on port 80. Now what is that doing? Well, that means this rule will only fire off if somebody's trying to access the web on that LAMP server, right? Okay, so then we would have to set up our message, whatever we want to say. Right, you see where I'm going? Now what is the SID? It's just an ID of this thing, okay? So you can see that there's some logic to this. I've been using some degree of numbering. Like, what are we over here? So we had rule 100,000 ID, and then we skipped one. I did, for whatever reason. Maybe I had one and deleted it, didn't like it, didn't work. And then I ultimately, had 2, 3, and 4. So sort of like with firewall rules, maybe I want to skip and give myself some space in case I want to add a couple more back in. So maybe we'll just go to 100. That's perfectly fine. We can do that all day. And then we have the rev, and we make sure, so that's what I thought. It was just rev : 1 semicolon. I think that's all. You see it's cutting off. So I'm having to pop back over to the end of the line to make sure. So yeah, number : rev number : make sure I got that here. Perfect. So that is the rule. I've created my own rule. I've given it a different numbering scheme. And of course I can save this. And now since that rule is included through the snort comp, when I restart snort, then it will process that rule. So I'll let you folks continue to play with that and make some additional rules for yourself. Let me make sure I'm not forgetting anything as we get close to the end here. No, I think that's about it. So cool. I'm going to go ahead and kill this. I'm going to stop my screen share. So yeah, that is pretty much wraps up the middle part of we went really fast through, of course, the first lesson, because I'm going to leave that mainly for you to play with completely. You're just going to read these case studies and answer, do some research, etc. And but then 5, 6, and 7 are all about intrusion detection, intrusion prevention. 5, the conceptual, though you do have a hands-on to build some at least sample topologies. And then you'll be back in the class topology, actually working with the live snort appliance in there, playing with this configuration, and ultimately creating some custom rules as well. All right, well, that's all I have for you folks today. This wraps up Logging and Monitoring Workshop 2. And this wraps up all 3 of the workshops I've done today. And so, as usual, it'll take me a little while to let Zoom process these. Then I will download them, get them posted up to our video, and put the links in the LMS. And then I will see some of you later this early evening and over the next couple of days for some one-on-ones. Have a good rest of the week. Thanks.